Hello, this is the project for Computer Science 110. My name is Diego, and my project consisted of building the five platonic solids but two complicated solids. So we're gonna move on. These are the guys that I was assigned to. So I'm gonna talk about how I built the first five and how I designed the net for them using Turtle from Python. So first for the tetrahedron, I basically defined a function having inputs for angles, distance, direction, and the name for the function. As you can see on my code, I will define whether I wanted to go right or left. Since I wanted my number of directions to be divided by 360 degrees, so I will just define theta as the degree angle for any solid, which in this case will be the tetrahedron. So for a triangle will be just 120. So therefore n will equal 3, and that will be the amount of turns Turtle will take in order to make the first solid. So I just repeated this process multiple times until I got this guy right here. Now I'd like to talk about the cube. Basically, I use the same ideal. I defined the general function. Now this time I had the angle to be 90 degrees instead. Let me just move right here. 90 degrees instead, so therefore we will have to, so Turtle will take 4 turns. And in this case, the distance I defined it to be 75. And then again, I repeated the same process for each square in order to draw the net for the cube. For the colors, since I forgot to mention how I did it with tetrahedron, I used the function from Turtle of begin fill, end fill for each face and the sign. Now I'd like to move on to the octahedron. Same ideal. Then again, since the octahedron, the net is composed of triangles, my code for this guy looks pretty similar to the tetrahedron, except I repeated the process multiple times in order to get the net, and I just define the direction and the distance, and then at some other times I will redefine the amount of turns of distances I would like Turtle to take, since it will be a different process. But then again, here's a sample of my code. It's a little bit longer than this since I added a little bit of face stage and also colors. So that's some of this guy right here. Now the dodecahedron. I really had a lot of fun with this guy. For this guy, I defined the angles of being 72 degrees, since when 360 divided by 72 will give you 5 turns. So in this guy, I just defined them as flowers basically. Here's a sample of my code. So I divided theta by 72, it would give you 5 turns, and this is a sample code of the first flower, meaning the first guy right here in the middle. And basically, for the faces, what I did, I repeated the same process, except I redefined the function as using the 120 degrees, so it would turn into a triangle. So therefore, I will start on one of the edges of the pentagon, and then use draw a triangle and coming back to the original place, and repeat the same process over a circle motion, therefore creating like this start pattern in the middle of one of the faces of the pentagon, and then so on, repeating all over. Now I'd like to move on to the icosahedron. Icosahedron was also pretty similar to the octahedron and the tetrahedron, since it also is composed of triangles. So I basically repeated the same process for the icosahedron, just like I did from the tetrahedron and the octahedron. and this time I had to arrange some of the things since the icosahedron had a little bit of like a more slanted pattern. So I will manually inject or apply 1 turn or 3 turns, since sometimes turtle will not be going back to the original place. So I will just fix a little bit of that, but it seems pretty straightforward. Once you define the angle of the polygon that you're using, then it's just very easy to use it as just like a compass loop. Now I'd like to move on to the complicated polyhedra. These two guys were definitely a little bit more challenging, but definitely have like the same ideal as far as building the net went as for the previous 5. And for the truncated icosahedron, aka the soccer ball, basically the patches on the soccer ball were pentagons and the rest of the compositions were hexagons. So if you take a look at my sample code, I only defined the function for the pentagons, and then I just re-entered a different angle degree for the hexagons. Therefore, Turtle will read it as drawing an hexagon instead. So once I got the first middle section right here, I would then move on into building the rest of the truncated icosahedron net, and I will just repeat the same process over and over all over the place of the net. So therefore some of these guys look like pentagons, like an example right here, 72 degrees, just one movement, the distance and which direction. And then some of these guys was on a 60-degree angle, meaning I would just build or draw a hexagon. Now to finalize, we have the great dodecahedron, which was a little bit more of the challenging one, since I was able to use most of the idea that I used throughout my entire project, which was just given an angle, I will tell Python or Turtle, excuse me, how many turns to take in order to build such pattern. But for this guy, since the angles vary so much, instead I went for little triangles. So if you take a look at my code right here, I started telling Turtle to take simple turns left and right at different degrees, so it will turn this very small triangle right here, let's say the yellow one in the middle, and then I will repeat the same process all over around, so therefore will create the first star in the middle. And then once having that idea behind it, here's the sample of code again, I would just repeat the same process, but except I would just build the outsides of it, which I kind of like define it as like wings, and just build the same amount of triangles every time with the same angles and the same idea that I used to just build the little star. And then again, the color, just by a simple function from Turtle of just end, begin, fill. And I think my code is going to be a little bit longer than this, obviously, since there's so many turns and so many of these little guys in order to build the entire net. But yeah, this project was a lot of fun. It was definitely a bit challenging, but yeah. Thank you very much for listening, and this was my project, and I hope this was for your help. Thank you very much.